right, Mrs. Smith, back at it. Here we go. Lesson 3.3, variables on both sides. Again, this is part of that chapter that you should have some prior knowledge, but everything that we do in algebra builds on all of these concepts. So, here we go. Variables on both sides. Should sound familiar. Simplify by using the distributive property or collecting like terms. You're going to put variables on one side and constants on the other, and then you're going to solve. So, let's get to work. So, looks like we have a distributive property that we need to take care of. And that distributive property is right here. I think I did distributive in blue. So, 2 times c is 2c. And 2 times negative 6 is negative 12. All right, going to copy everything else over. 9c plus 2. I don't have any collecting of like terms. So I'm going to go to the next step. Variables on one side and constants on the other. So you can decide how you want to do this. You're going to put variables on one side and constants on the other. I tend to look at my variables. And I have a 2c and I have a 9c and I have a 2c. Personally, if I can avoid negatives, I do, just because, I want to make life as simple as possible. So I'm thinking I have positive 9c over here. I only have 2 over here. So I'm going to make this my variable side. You can do either, because if you remember from last year, you probably did them both ways and found out you'll get the same answer. So I'm going to put my constants, which is just a fancy name for numbers, on the other. So variables on one side, constants on the other. All right, in order to do that, I usually move my variables first. So I recommend that. You don't have to. You could move your constants first, but I like to kind of keep things in order, so I usually do variables. So these cancel. Bring down a negative 12 equals 9c minus 2c is 7c, and then plus 2. So this is my variable side, and this is a constant, so I have to move it over. You can think of it as that, or you can just see, geez, I have a two-step equation. I'm an expert at two-step equations. I just have to isolate the variable and solve. So I'm going to subtract 2 and subtract 2. So I have negative 12 minus 2, which is negative 14. And I bring down my 7c, and then those cancel. Then, again, isolate and solve. So I divide by 7, and those cancel. And c equals, be careful with the negative sign, negative 14 divided by 7, which is negative 2. Again, not anything really that new, just reviewing. All right, so we're going to do the same on this side. I have to simplify using the distributive property. I'm going to do that first. Got some distributive properties over here that I need to take care of. So 2 times n is 2n. 2 times 1 is 2. Plus, got some more distributive property, and I can always tell because there's some parentheses with the number smushed on the outside. So 3 times n is 3n. 3 times negative 1 is negative 3. All right, taking care of that, I'm going to bring down my 4n. Now, looks like I still need to collect some like terms. There's some simplifying that I need to do over here. So I'm going to combine, I'm going to leave 4n alone. Let me write that down. So 4n equals, now I have an n and I have a 2. So I have a variable, a constant, a variable, and a constant. So let's put those together before I do any moving. So 2n plus 3n. 2n plus 3n is 5n, and then maybe I'll circle my constants. 2 minus 3, and 2 minus 3 is negative 1. All right, now I've taken care of distributive property. I've taken care of collecting like terms. So now I'm going to put variables on one side and constants on the other. Now, take a look at this one. This one already has a variable all by itself. Now I usually I use the bigger number to avoid negative numbers, but this one's already isolated with the variable. So I'm going to make this my variable side, seeing it's already kind of isolated, and I'm going to make this my constant side. So in order to do that, I'm going to move this 5n to the other side. So I'm going to subtract 5n and subtract 5n. So when I do that, 4 minus 5n is negative 1n, and you can write the 1, but you don't have to. You can just write negative n. And then these cancel and brings down a negative 1. Now, still not isolated, still not finished, not simplified enough. So I got to get rid of the negative 1, so I'm going to divide by negative 1, divide by negative 1. So that gives me n equals negative 1 divided by negative 1 is 1. And n equals 1. All right. So now I'm going to probably introduce a new word to you that you have not heard, and that you have not heard, and that word is identity. Identity is an equation that is true for every value of the variable. Sometimes they'll say the solution is all real numbers, meaning everything that you put in there works. You put 2 in, it works. You put in negative 622, it works. You put in 3/4, it works. You might also know this, this symbol, infinity. This is also known as infinitely many solutions. So again, you should be familiar with infinitely many solutions, but now we're just taking it up a notch, I think just to confuse you, but that's the algebra in the mathematical world. We're going to now call it an identity. So I have 10 minus 8a equals 2 parentheses 5 minus 4a. All right, let me put my line down the center, all about keeping balance. It looks like I got a distributive property to do. So I have 2 times 5, which is 10, and I have 2 minus 4a, which is negative 8a. I bring the other ones down, and I have 10 minus 8a equals 10 minus 8a. Oh, that's interesting. All right, but I'm going to put variables on one side and constants on the other. Let's see. Got a negative 8a, negative, so I guess it really doesn't matter. Let me make this my variable side. Let me make this my constant side. So let's move this guy. So I'm going to put 8a over here and 8a over here. So I have 10, and then I have negative 8 and a positive 8. Uh-oh, those cancel. Equals 10, and I have a negative 8 and a positive 8a. They cancel. Well, that's interesting. Now I'm going to put my constants over here. So what happens is I'm going to subtract 10 and subtract 10. And now I have 0 equals 0. And that's what happens every single time you have an identity. You have 0 equals 0. Everything ends up canceling out. Okay? So when everything cancels out and you have a 0 equals 0, you stop there and you write identity. Okay? So let's talk about this for a second. So you have identity. Now, you might have noticed, and I said, oh, that looks interesting, and I kind of noted that right here. So I have right here that it was 10 minus 8a equals 10 minus 8a. What do you notice about that? Is that exactly the same on the left side as it is the right side? It is. Whenever you find that, after you've simplified, after you've done the distributive property collecting like terms, if you see that one side is identical to the other, you can stop there. Do I need to see all the rest of this stuff? No. And in fact, if you notice that pattern, that makes you a better math student. And I want you just to stop there, ignore all of this, and write identity. Did you hear my word identical? Identity. Do you see where they got the word identity from? It is identical on one side and the other. All right, so here we go. Let's do another one. So I draw a line down the center. Looks like I have nothing to do over here, but some collecting of like terms to do over here. I have 7m minus m. So 7m minus m is 6m. Geez, that's a tongue twister. So now I have 6m minus 5 equals 6m, and then plus 7. Interesting. We'll come back to that in a second. All right, we're going to make variables on one side and constants on the other. Looks like they're both positive and they're both the same. So I'm going to make this my variable side, make this my constant side. So that means I'm going to move this 6m over to the other side. Make sure you're writing this down, and if you need to pause the video, you certainly may do so. So these cancel. That gives me negative 5 equals, these cancel, and that gives me 7. What? Hold on. Hold the phone. Does negative 5 equal 7? Can negative 5 equal 7? If you say yes to that question, then you know what? I'll be the person with $7 and you be the person with negative 5 in the hole where you owe somebody $5. Is it the same? Absolutely not. So this, ladies and gentlemen, when you have negative 5 and 7, do not equal each other. So I'm going to put a slash through that equal sign. Have you seen that before? Meaning it's not equal. And this is no solution. So when they were identical, we call that an identity. When one side doesn't equal the other, we call that no solution. Now, I said, that's interesting. Let's go right back up to here. And it says 6m minus 5, and it says 6m plus 7. If you notice when you're doing the math after you do the distributive property and collecting like terms, if you notice that they have the same variable but different constants, you can stop right there. I don't need to see the rest of this because this means you're looking for a pattern. You notice something, aha, and you can immediately say, no solution, because there's no way that negative 5 is going to equal negative 7 because those variables are going to cancel. So you can stop there. Please make sure you always show me, the distributive property and collecting like terms. But once you get to there and you can prove it to me, yep, I know it's no solution, I don't need to see the rest of this. So if I go back through for identity, they have both the same variable and the same constant. And I'm just going to abbreviate both of those. Over here, no solution has the same variable, but they have different constants. So be good math students and look for patterns. That's one of our mathematical practices we want you to do anyway. So if you notice, you can stop there. All right, we're going to try just a few more out to see what you got going on. Let's make sure that this is in the, looking good. All right, so here we go. One side and the other. Looks like I actually have a distributive property there. It isn't a number. There isn't a number smushed on the outside, but it's kind of that ghostly Gladys one, I call it. I have a ghost I call Gladys. And ghostly Gladys really kind of comes into effect here. It's a 1. So you have a negative 1 times 2q plus 5. So I do have a distributive property. I'm going to do that first. So I'm going to copy the 14 down. Just bring it on down. And then I have negative 1 times 2q is negative 2q. And I have negative 1 times 5, which is negative 5, equals, and now on the other side I have negative 2q plus 9. Alrighty, looks like now I have some collecting of like terms. I've got some constants that I need to collect before I do any moving of stuff. So I have 14 minus 5. 14 minus 5 is 9. And then I have minus 2q equals negative 2q plus 9. Whoa, hold the phone. Do you notice something? Hopefully you were like, oh, I see it, Mrs. Smith. Negative 2q and negative 2q. Same. 9, 9. Same. So we can stop there. We don't need to do the rest. I'm going to go right here. I notice, I'm a smart cookie. I notice the pattern. And this would be, they're identical on one side and identical on the other. So they are an identity. All right, let's do this one. Draw my line. I have 6b plus 14 equals negative 7 minus b. No distributive properties. No collecting like terms. So I'm going to make one side my variable side. This is a 6b. I'll make this variables. And then I'm going to make this my constants. All right, so I'm going to move that variable over. So I'm going to add plus b. Could I make it a 1b? I could. Plus b. Or a 1b is fine. All right, when I do that, I have 6b plus 1b is 7b plus 14 equals negative 7. These cancel. All right, two-step equation. So I keep working. isolate the variable. So I'm going to subtract 14 to the other side. So that gives me 7b minus negative 7 minus 14 is negative 28. Don't forget that negative sign. Boy, that's a mistake I see. Oh, not 28, Mrs. Smith. Were you hollering at me at the screen? How about negative 21? Sorry about that. All right, and then divide by 7, divide by 7. And b is equal to negative 3. This is referred to as something that has one solution. And what I want to do is I want you to kind of go back up to even the very beginning right here, and I want you to look for patterns. If you've got everything simplified, you've done the distributive property, you've collected like terms, and you notice that here you have a 6b, and on the other side your variable is not the same, it's a negative 1b, not the same, then you are always going to have one solution. So that's just another little like check process that you can rely on to help you out. So if your variables are not the same, then you know I need to keep going. I need to solve it all the way through and get one solution. All right, last but not least, and of course if you want to pause the video and try it out yourself to see what happens, be my guest. I think that's a great idea. So, distributive properties I'm looking for. Here's one. 3 times negative 3. Excuse me, not 3 times negative 3. 3 times 3x, which would be 9x. And 3 times x is 3x. Equals. I'm going to bring all of this. You know what? I'm not going to bring it down. I'm going to save myself some work. Look at here. I have 9x plus 3x, which is 12x. And then I'm going to write minus 10. All right. Now, looks like I have some collecting like terms because those are both variables. They're both x's, so I'm going to collect some like terms over here. Just going to bring this down. 12x minus 10 equals 9x plus 3x is 12x. And then nothing. Stop. Hold the phone. Do you notice something? I noticed that I have the same variable, 12x and 12x. Here, the constant is a negative 10. And what's the constant over here? There's nothing there. Could I put in a 0? Yep. So in the end, those variables would cancel, and it would be negative 10 equals 0. Can negative 10 equal 0? Absolutely not. So we would write no solution. So there you have it. Variables on both sides with something new called an identity, which is the same thing as infinitely many solutions, and it's identical on both sides, and that's how they get the word identical identity.